My name is David McCauley, and I'm with the Astro Society of Kansas City, and we're down at Powell Observatory in Lewisburg, Kansas, and we're going to put together a little tutorial on how to do live stacking with the Ruisinger telescope here at Powell Observatory. The camera's sensor is about 30 or 40 times more sensitive than the human eye. So with a 20-second exposure or a 30-second exposure with the camera, we can capture colors and beauty in the sky that your eye just can't see. And what live stacking does is take a series of relatively short photographs, 10 seconds, 20 seconds, maybe 30 seconds per exposure, and then average them together by stacking them on top of each other and projecting that on a computer screen out to the audience that's watching the live stacking. The stacking accomplishes several things. One is it gives us immediate feedback. We know within 20 seconds whether we've gotten to our target. And then as you watch and talk about the target, the picture gets better and better because each new layer that's stacked on top improves the signal-to-noise ratio. The noise kind of cancels itself out, the signal reinforces itself, so as the stack gets deeper and deeper, the picture gets better and better. Then we move the telescope to a new target and repeat that process until everybody's tired or the clouds roll in or we just decide it's time to quit. So what I want to do now is walk us through, for the benefit of the club members who have to run this equipment, how our new setup works, so that if you are assigned the live stacking duty for your team, you can feel comfortable that you know how to do it. Get the equipment out. You need to be either a key holder or have a key holder with you, because we keep the necessary equipment in this cabinet over here on the left-hand side of the room. So for those of you who are familiar with astrophotography, you may recognize this is a ZWO 071 Astro camera. It's a color camera. It has a sensor chip that's about the size of an APS-C sensor in a standard DSLR, roughly 20 megapixels. It's able to be cooled to about 25 or 30 degrees centigrade below the ambient temperature, which reduces the noise and makes for better pictures. We have a focuser, an electronic focuser, and we'll go through the process of hooking the camera in the focuser up. And then to make it all work, we built a kind of a funky looking control board that wires up the electronics so that we can control everything on the telescope from in here, where it's either warmer if we're in the winter or colder if it's in the summer. We're going to put the equipment on the front of the telescope that is necessary to drive the camera, and I'm going to walk through what the equipment looks like, what it does, where to put it, which cables go where. Just to orient, the telescope is sort of pointing down so that I can reach the focuser. And I've done things like take the cover off the telescope, all that stuff that we have reviewed in other videos. Step one is to take the visual focuser off of the camera, off of the telescope, and replace it with the electronic focuser. There's 4 knobs that need to come off, and this thing slides off. And then there's a plate of the same size that has the electronic focuser that goes on. When you put it on, you try to put it on so that it sits flush. It's easy if you're not careful to get it tilted, and that'll mess up your images. We have the same bolts that held the visual focuser in place hold the electronic focuser in place. With one exception, this lower left-hand corner bolt can't go on because we need to keep access to this little plug-in here. So you'll put 3 of the 4 bolts on, cinch them down roughly equal, make sure everything is kind of flat. Before you put this focuser up here, you can adjust the height of the draw tube so that focus is close to being where it's going to need to be once we have the camera on. I've got in the documentation that you'll have a link to the exact dimensions of how high the top of this should be from the gold plate here to be an approximate focus. You can just use these knobs to dial it up and down. I've already done that, but the documentation contains the details. If you didn't do that, it's no problem. It just is a little bit harder to find focus. So step one, put the focuser in place. Then we can hook the camera up. I'm not going to do any dusting of the camera, but typically take an air squeegee thing and blow the dust off the camera lens or the camera filter, because it always accumulates dust, and the dust can be pretty distracting. On the front of the camera, by default, there's a clear filter that's an infrared ultraviolet filter. This filter is necessary with this camera to prevent the stars from bloating. If you put a different filter, like an L-enhance or a narrowband filter of some kind, you don't need this filter. But if you don't have one of the other filters, make sure that that infrared UV filter is in place. Then the camera, I'll point out, the camera has a little ring that we 3D printed, this little gray plastic ring. That ring helps position the camera's distance in conjunction with the setting that we have on the focuser so that it's roughly in focus. That's what that's for. Don't lose it. You can orient the camera whatever angle you want, and depending upon what you're trying to take a picture of, you may want something that's not just straight up and down. But by default, we put the name of the camera at the bottom, parallel to the long axis of the telescope, and the camera vertical now then aligns with north and south, so that when the camera's in the sky, it's what they call north up. The short edge of the rectangle will be facing Polaris. And then tighten these 3 compression screws so the camera's nice and sturdy. And I always put the camera cap in my pocket so that when I'm reversing this process at the end of the evening, I know where it is, because otherwise it's dark and black and it'll get lost. And then finally, the third step is to hook up this little control board that looks scarily complicated, but really isn't. You'll notice there's a Losmandy style saddle plate here and here, and the plate has a Losmandy clamp on the back. So you position it and lock it down so that it's pretty tight, because it's going to be turned upside down and everything. I usually line it up so that the edge of the plate and the edge of the Losmandy saddle are in alignment. It's not critical, but it's just a nice reference point. And then once the plate's in place, we hook up all the cables. But let me talk through what these devices do so that it's not as mysterious as it looks. This doesn't, it kind of looks like you're defusing a bomb or something, but it's actually pretty straightforward, and most of it is pre-wired. Coming up this telescope from the bottom, we have 12 volts from a brick down at the base of the telescope. That goes into this blue Pegasus, what's it called? It's a Pocket Power Box Advance from Pegasus. And this box serves 2 purposes. One is it divides the 12 volts up so that I can power multiple devices with one 12-volt line. And second, it's a USB hub that multiplexes the signals out from the camera and the focus motor so that I can send it down to the computer over one USB line. So step 1 is to plug the 12-volt line in. Step 2 is to plug the USB 3 line in. This old gray cable is only used in special circumstances, not typically needed, so you can ignore it. But these 2 cables carry the USB signal down, 12 volts up. Then this box supplies 12 volts out of one of these cables here over to the Moonlight controller. So this is the controller that drives this focus motor, and it gets connected up with this old DB9, I think it is, plug that screws in to the focus motor there. So that will let you control the focus motor up here with these 2 buttons. That'll make them move in and out, or from the computer in the closet over the USB cable. And then finally, but last and not least, obviously, is the camera has to get hooked up. There's a USB plug for the signal and a 12-volt plug that drives the cooling engine in the camera. So that's it for hooking it up. Connect the 12-volt line and the USB line that run down. Connect the focus motor's serial control cable, the USB to the camera, and the 12 volts to the camera. Make sure it's nice and snug, and you should be able to go. Now what I like to do before I send it back up out of reach is plug the transformer in, or the power brick in, and make sure that everything lights up. There's a little lights up here, because if it doesn't, you probably should want to fix it before you put the telescope back up in the sky. So let me go plug that in. It's just a standard power brick. We have a little plug down here, and it goes in. A little red light on the camera lights up, so the camera's getting power, and then there's a little blue light on this Pegasus box that you won't be able to see it on the camera, but it's obviously lit. And sometimes the camera's cooling fan will start spinning. That's normal. From this point, we go through a standard alignment of the telescope with Maestro, except in this case, you're obviously going to fine-tune the alignment not by looking through a visual eyepiece and a reticle, but you're going to use the computer and the computer's camera and a reticle on the computer screen to verify that you're pointed at your alignment target.